All right, we are going to do notes 2.1, power and radical functions. There is a PowerPoint on Google Classroom. There is a PDF of the PowerPoint on Google Classroom. I tried to upload it into Google Slides, but some of the formatting got messed up, so it wasn't very useful. At least I didn't think it was. There is a copy of these blank notes, and then when I'm done with these, providing it all goes well, I will upload my copy to Google Classroom. Also, there's also 2 videos there that you can view from YouTube. All right, so looking at this is a flashback from like first trimester when we did the end behavior, like the limits and increasing, decreasing, whether or not something's continuous, the max and relative, absolute, extremas, even and odd behavior, and symmetry. So these are different looking graphs, but the content and the way that you describe them would be the same. So when I'm looking at these, a lot of the times I have an idea of what they look like, but I would guess, but if you graph them either on Desmos or some other function, you'll be able to see a visual picture and see what it looks like. So you'll be able to answer these questions probably much quicker. So when we are doing your graphing and your analyzing of the graphs, remember the even odd power. Even is if your exponent is an even number, and if your exponent is an odd number, it's an odd power graph. Now, if the number in front of your x is a positive, both arms are going to go in the same direction. If both arms, or if it's negative and it's an even function, they'll both go down. Hopefully you guys are remembering this. If it is a positive constant, but the exponent is odd, the arms are going to go in opposite directions. This one's going up, this one's going down. If your constant in front of your x is less than 0 or negative, it's going to be decreasing from left to right. So it has like a downhill slope rather than the uphill slope that you're used to. But because this is an odd, if it was odd, your arms of your graph are going to be going in opposite directions. All right, does that make sense? Hopefully it does. This is all review type of things. Okay, so our first example is 1/2 x to the 6th power. So notice we have an even, so arms are going in the same direction. We change the thickness of this. Arms are the same. All right, and then this is positive. So we're going to be increasing, okay, from left to right. So we're going to analyze the rest of that. So the first thing is domain. Now this is similar to a quadratic graph. I'm not saying it looks exactly like a quadratic graph. All we care about is the left and rightmost area. So we're looking at something like that. It might do some weird stuff in the middle, but we really only care about the left and the right. So the domain is all your x values, and do we have to eliminate any of those x values? So in this case, we don't have a square root to worry about, so we don't need to worry about negatives under a square root, and we don't have a denominator, so we don't have to worry about getting a 0 in the denominator. So in that case, all real numbers are useful here, so we don't have to worry about anything. Or remember, you guys could say maybe negative infinity to infinity. That was another way you could write it. Range, with this one, it doesn't go below the x-axis because it's even and it's positive. So both arms are going up and it's increasing. So we can say that from 0 to infinity, from 0 to y equals infinity, remember that's y values. And remember, the bracket means we can touch 0. The parenthesis means it doesn't actually hit the infinity. All right, intercepts. Does it cross anywhere? It doesn't actually cross, but it does touch, even though my graph doesn't show it. It grazes it at 0, 0, so that would count as an intercept. end behavior. That is your limit. So this is that limit as x approaches negative infinity and as x approaches positive infinity. So with this case, I'm going to make this a little bit bigger. All right, with this case, as x approaches negative infinity, your graph is going higher and higher and higher, meaning the y values are going higher and higher and higher. So as x goes this way, your y is going up. So as x goes that way, y is increasing. So we're going to say as x values get closer to negative infinity, y values go to positive infinity. Usually we say f of x, but all right. And if we go the opposite direction, let me change colors, as x values get positive, the y values go up. So as x gets bigger and bigger, y is going up. So we are just going to say the same thing here. As soon as I change to a pen, y goes to infinity. All right, is this graph continuous? Meaning, is there any jumps, asymptotes, or holes? Nope, there's none of those. So yes, it's continuous across all real numbers of the domain. All right, is this graph increasing or decreasing? Remember when we do that, we read it from left to right. So left to right. So from left to right, this graph decreases from negative infinity, remember x values. So y values decrease, which we should really say over here. Y decreases as x values go from 0 or negative infinity to 0. As x goes from negative infinity to 0. Let me say that or write that a little bit better. Hold on. Sorry, so y values decrease as x values go from negative infinity to 0, and likewise, this graph increases. So the y values increase as x goes from 0 to infinity. All right, and then symmetry. Is this symmetric to the x-axis, y-axis, or origin? Well, if we folded it, right here, if we folded it across the y-axis, then it would overlap perfectly. So that is even symmetry, which is across the y-axis. So we can say y-axis here, and that's even. Remember, if it is symmetric across the x-axis, it actually doesn't have a name. And if it's symmetric across the origin, it is odd. Asymptotes. Are there any asymptotes in this graph? No asymptotes. No square roots, no denominators, so no asymptotes. And absolute, minimum, maximum, or relative minimum, max. There is one like valley, one minimum, and it's the absolute. So absolute, if I could spell, which we all know I can't. And remember, it's a minimum, and it's at 0, 0. All right, so on to the next example.